In the summer of 1941, Wehrmacht tank crews ran into a machine for the first time that made them question everything they thought they knew about armored warfare. Shells bounced off its sloped armor, and its return fire destroyed their vehicles from distances where they couldn't even take aim. Commanders sent frantic reports back to Berlin, demanding answers about this unknown tank that had suddenly appeared on the battlefield. That machine was the T-34, and it forced a serious rethinking of how armored warfare worked. Wehrmacht generals had gotten used to quick victories across Europe, where their Panzer IIIs and Panzer IVs had no real trouble dealing with French and British tanks. Blitzkrieg worked like clockwork. Armored spearheads punched through enemy defenses, and it seemed like the same playbook would work just as well across the vast terrain of the Eastern Front. But reality had other plans, and the very first clashes with these new tanks showed just how badly the High Command had underestimated what they were up against. When crews reported that their 37mm guns couldn't punch through enemy armor even at point-blank range, nobody believed them at first. But the reports kept flooding in from every sector, and ignoring them was no longer an option. The battle near Mtsensk in October of 1941 left a particularly deep mark. The 4th Tank Brigade under Colonel Kadakov's command hit the Wehrmacht's 3rd and 4th Panzer Divisions hard enough to slow their advance. The Soviet tankers fought from ambush, taking full advantage of the edge their machines had in both armor and firepower. T-34s would pop up out of nowhere, tear through enemy columns, and disappear before anyone could respond. Over several days of fighting, the division lost dozens of tanks, and the commander of the 2nd Panzer Group, General Guderian, had no choice but to acknowledge that the enemy's equipment was simply better. It was after these events that he wrote a memorandum to High Command, pushing hard for the immediate development of a new tank that could go toe-to-toe with these machines. Captured T-34s were immediately shipped to the rear for a thorough teardown. Engineers took the tanks apart down to the last bolt, trying to crack the secret of their effectiveness. And the deeper they dug, the more they appreciated certain design choices. The sloped arrangement of the armor plates dramatically increased their effective thickness. Wide tracks gave the tank excellent cross-country mobility through mud and snow. A powerful diesel engine proved both reliable and fuel-efficient. At the same time, the tank had obvious shortcomings: a cramped two-man turret, poor optics, and rough build quality that varied wildly from factory to factory. But the core design concepts were sound, and it was those concepts that impressed the German engineers most. In December of 1941, 2 firms, Daimler-Benz and MAN, were tasked with developing a new medium tank that could match and counter the T-34. The technical requirements specifically called for incorporating the design solutions discovered during the study of captured vehicles. In other words, the engineers were told to build a better version of the T-34, layering their own precision and manufacturing quality on top of the design concepts they'd found. The project was codenamed Panther, and expectations were enormous. The competition between the 2 firms was intense. Daimler-Benz went down the path of maximum imitation. Their design featured a diesel engine, a rear-mounted turret, and an overall layout nearly identical to the T-34. Visually, their tank looked so much like the original that there were real concerns about friendly fire on the battlefield. MAN took a different approach, keeping the traditional layout with a front-mounted transmission and a centrally placed turret. They borrowed only the key innovations: the sloped armor and the running gear with large road wheels. Hitler personally reviewed both proposals and initially favored the Daimler-Benz version, which struck him as more revolutionary. But military experts flagged serious drawbacks in that design. A turret at the rear of the hull limited the firing arc, and a diesel engine would have meant overhauling the Army's entire fuel supply chain, which was built around gasoline. In the end, the MAN design won, and it was the one that went into mass production. Daimler-Benz was ordered to build tanks based on their competitors' blueprints, a serious blow to their prestige. By September of 1942, the prototype was ready for testing. The machine turned out to be impressive. The Maybach HL-230 engine became the beating heart of the new tank. 12 cylinders in a V configuration produced 700 horsepower, pushing the 45-ton machine to about 34 miles per hour on paved roads. For context, the T-34, weighing roughly 30 tons, topped out at about the same speed. The engineers deliberately went with a gasoline engine over diesel, even though the captured tank ran on diesel fuel. The reasoning was practical. The entire Wehrmacht supply chain was built around gasoline, and retooling logistics for a single model was considered a waste. This decision would later come back to bite the Panther, but at the time, nobody gave it a second thought. The power plant weighed around 2,600 pounds and sat in the rear of the hull. From there, torque was transmitted through a drive shaft to the transmission up front in the nose. This layout was traditional and had its perks. The driver sat right next to the gearbox and could feel how it was working, and the drive sprockets up front simplified steering. But the long drive shaft ran through the entire fighting compartment, raising the floor and making the vehicle taller overall. On top of that, any transmission damage meant pulling it out through the front of the hull, which under field conditions turned into an absolute nightmare. The AK-7 200 gearbox was a complex piece of machinery with 7 forward gears and 1 reverse. Synchromesh on every gear made shifting smooth, and semi-automatic controls eased the strain on the driver. This transmission was considered an engineering masterpiece, but its extreme complexity came with a serious downside. Any breakdown called for skilled repair under factory conditions. Fixing this unit in the field was virtually impossible, and tanks with a busted transmission often had to be left behind. The Panther's armor protection clearly showed the impact of studying the T-34. The upper glacis plate, 80 millimeters thick, was angled at 55 degrees from vertical. At that angle, the effective thickness came out to about 140 millimeters, which actually beat even the heavy Tiger with its flat 100 millimeter plate. Rounds from most anti-tank guns simply ricocheted off this armor. The lower glacis was 65 millimeters thick at the same angle and also held up well. But the designers made a serious miscalculation with the side armor. While the front could take hits from virtually any tank gun of the era, the sides had only 40 millimeters of steel. Even a standard 45 millimeter anti-tank gun could punch through at reasonable ranges. The ammunition was stored right in the side sponsons, and a hit to this area almost guaranteed a catastrophic ammo cook-off. The tank would go up like a torch, and the crew had no chance of getting out. To partially address this weakness, 5 millimeter side skirts were added, but they only helped against shaped charge rounds and anti-tank rifles. The Panther's turret was welded from rolled armor plates, 45 millimeters on the sides, and between 100 and 110 millimeters around the gun mantlet. Rotation was powered by a hydraulic mechanism driven off the main engine. A full turret rotation took about 15 seconds, which was considered good enough. There was also a manual backup, but a full rotation by hand required over 1,000 turns of the handwheel. A real headache was the turret's imbalance relative to the turret ring. If the tank was sitting on a slope, the turret would start drifting on its own toward the low side, and holding it in place took serious effort. The Panther's real trump card was its gun. The 75 millimeter KWK-42, with a barrel length of 70 calibers, had phenomenal ballistics. A sub-caliber round left the muzzle at over 3,300 feet per second, and the flat trajectory held out to about 1.25 miles. In testing, the Panther reliably knocked out enemy tanks from ranges where they couldn't even shoot back. Its armor penetration actually exceeded that of the Tiger's famous 88 millimeter gun at medium ranges, despite the noticeably smaller caliber. On later variants, the ammo capacity reached 82 rounds, giving the tank excellent staying power in a fight. The optics were top-notch. The gunner's telescopic sight with 5 times magnification allowed confident target identification and engagement at extreme distances. The commander sat behind the gunner in the turret and had a cupola fitted with 7 periscopes, providing 360-degree observation. The crew was 5 men: commander, gunner, loader, driver, and a radio operator, who also manned the whole machine gun. Each had his own job, which kept the crew efficient. The running gear featured 8 interleaved double road wheels of large diameter on each side. This setup delivered excellent ride smoothness and even load distribution across the track. The wide tracks, about 26 inches across, gave excellent traction on soft ground. The front and rear wheel pairs had hydraulic shock absorbers that dampened vibrations over rough terrain. Driving the Panther was surprisingly easy for such a heavy machine, and drivers often praised how comfortable it was behind the controls. But all these advantages came at the cost of insane maintenance complexity. More on that later. On July 5, 1943, Operation Citadel kicked off, and the Panthers went into battle for the very first time. Command had pinned special hopes on the new tanks, concentrating around 200 Panthers in the 39th Panzer Regiment, part of the 10th Panzer Brigade on the southern face of the Kursk salient. The brigade also included Panzer IIIs, Panzer IVs, and a handful of Tigers, but it was the Panthers that everyone was watching. It was the largest concentration of Panthers in the entire war, and the generals were counting on them to smash through and turn the tide. Reality had other ideas, and the very first hours of the offensive showed just how unready the new machine really was. The problem started on the march to the jump-off positions, before they even reached the front line. Tanks burst into flames right on the road, not from any enemy fire, but from their own design flaws. Fuel lines routed too close to the red-hot exhaust manifolds would spring leaks, and gasoline would ignite from the engine heat. Crews barely had time to bail out of their burning machines, leaving brand-new tanks sitting in the middle of open fields. Of the 200 Panthers that started the march, 16 broke down before the offensive even began. Those that did make it into combat were quickly whittled down by a combination of mechanical failures and enemy fire. They ran straight into fierce resistance. The defenders, well aware the offensive was coming, had built deeply layered defenses packed with anti-tank guns. The gun crews quickly figured out that the frontal armor on these new tanks was practically invulnerable, so they shifted their fire to the flanks. Panthers trying to maneuver under fire exposed their thinly protected sides and caught fire from the very first hit. Shells slammed into the side sponsons where the ammo was stored, and the crews died instantly, without even understanding what had happened. Panther commanders noticed another nasty problem. The long-barreled gun that was the pride of the designers turned into a liability when crossing trenches and ditches. The barrel would dig into the dirt, the turret would jam, and the tank would become a sitting duck. Swinging the gun toward a new threat took precious seconds that simply didn't exist in the heat of a fight. Tank-hunting infantry would close in on immobilized vehicles and shoot them through the thin rear armor and running gear. Transmission problems hit catastrophic levels. The final drives, designed for a tank weighing 35 tons, couldn't handle the real-world 45. The gear teeth wore down after just a few dozen miles, and the machine would grind to a halt. By the evening of the very first day, the number of operational Panthers had already dropped dramatically, and most losses were mechanical breakdowns, not combat damage. Within just 2 days, the number of battle-ready Panthers had plunged to around 40. By the end of the first week, the 39th Panzer Regiment had effectively ceased to exist as a fighting force. Repairmen managed to keep between 20 and 40 Panthers running on any given day, but the unit never came close to recovering its original strength. Repair crews worked around the clock, but couldn't keep up with the flood of broken-down vehicles. Spare parts were scarce, specialized equipment was hard to find, and recovering damaged tanks from the battlefield was incredibly difficult because of their weight. Standard recovery vehicles, based on half-track prime movers, couldn't budge a 45-ton Hulk, so they had to chain several vehicles together. Several knocked-out Panthers were captured in nearly undamaged condition. The machines were thoroughly examined, weaknesses identified, and tactics developed for countering them. The interleaved suspension drew particular interest. The engineers called it absurdly complex for field repair. Replacing a single inner road wheel meant removing up to 3 outer ones, a job that took several hours even for an experienced crew. Under frontline conditions, this kind of work was practically impossible. Anti-tank gun crews received clear instructions on how to fight the new tanks. Fire should be directed at the sides and rear, avoiding the frontal armor. Ambushes proved especially effective, with anti-tank guns positioned on the flanks of likely approach routes. Panthers focused on breaking through the defenses ahead, would take flanking fire and couldn't turn fast enough to shoot back. Gun crews would knock out several machines before the enemy even figured out where the shooting was coming from. Another major problem was the commander's poor situational awareness. The commander's cupola offered a decent view, but the main turret traverse had no commander override. To swing the gun onto a spotted target, the commander had to call out instructions to the gunner verbally, which burned precious time. In fast-moving engagements at direct fire ranges, those seconds decided who lived and who died. The disaster at Kursk forced high command to admit that the Panther had been rushed into battle too soon. Designers scrambled to fix the identified problems. Fuel lines were rerouted away from hot engine components. The final drives were reinforced, and the lubrication system was reworked. By the fall of 1943, most of the teething problems had been sorted out, and the tank's reliability improved noticeably. But the window had closed. The strategic initiative had shifted, and from here on, the Panthers would be defending, not attacking. The new weapon never lived up to the hype, becoming instead a cautionary tale of rushing things to the front before they were ready. Through the fall and winter of 1943, factories kept turning out Panthers, gradually incorporating design fixes. The A variant replaced the initial D version, featuring a reinforced commander's cupola and an improved engine cooling system. Engineers redesigned the fuel system, routing the fuel lines away from the scorching engine parts, and spontaneous fires dropped sharply. The final drives were strengthened, though the reliability issues were never fully solved. The tank got noticeably more dependable, but frontline reports still overflowed with accounts of mechanical failures. The operational readiness of Panther-equipped units rarely broke 50%, even during quiet periods. Out of every 10 machines, only 5 or 6 would be running. The rest sat waiting for repairs or spare parts. T-34 units generally fared better on this front, though their actual readiness numbers varied widely depending on the period and the unit. The Panther's complexity worked against it. Where a single mechanic could fix a T-34 with basic tools in a couple of hours, a Panther crew had to wait days for a specialized repair team. The interleaved suspension that gave such a smooth ride became a genuine curse for the maintenance crews. The large-diameter road wheels were arranged in 3 overlapping rows, and getting to the inner components meant pulling off the outer ones. Replacing one damaged wheel took hours of work by an entire crew using lifting equipment. On the Eastern Front, this design quirk turned into yet another headache. Mud and snow would pack between the wheels, and an overnight freeze would turn the whole mess into a solid block of ice. Come morning, crews would find their machines frozen to the ground and unable to move. They'd spend hours chipping away ice with crowbars, or lighting fires under the running gear, risking damage to the rubber rims on the road wheels. Meanwhile, Allied strategic bombing was doing increasingly serious damage to the industrial base. Factories producing alloying additives for tank armor became priority targets. Molybdenum, vanadium, and nickel grew scarce, and metallurgists were forced to alter the steel recipes. The armor plates on later production runs kept the same thickness, but their quality steadily declined. Shells that previously bounced off the glacis plate now punched through it or caused dangerous spalling on the inside. Armor fragments wounded crew members as badly as the enemy rounds themselves. By the summer of 1944, the G variant entered production, the most numerous and most refined version of the Panther. The designers took frontline experience into account and made a number of improvements. The driver's hatch was relocated to the upper glacis plate, eliminating a vulnerable spot at the front of the hull. The lower side armor was reinforced with additional 5mm screens. Ammo capacity was bumped up to 82 rounds, and the stowage was partially moved to less vulnerable locations. The machine became noticeably more lethal, but the strategic situation had already changed beyond the point of no return. On June 6th, the Allies landed in Normandy, opening a second front in Europe. The Panthers now had to fight under entirely new conditions. Narrow roads hemmed in by thick hedgerows, tight streets of French villages, fields cut up by earthen embankments. This wasn't the wide-open terrain where you could pick off the enemy from over a mile away. Fighting happened at short ranges, often within line of sight, and the advantages of that long-range gun basically evaporated. American and British tankers quickly developed tactics for dealing with Panthers in this kind of terrain. One Sherman would draw attention with fire from the front, while the others worked around the flanks. While the Panther's turrets slowly traversed toward the new threat, a second or third tank would already be lined up for a confident side shot. The long barrel of the 75mm gun snagged on hedgerows and building walls, making it tough to maneuver in tight spaces. Panther commanders noted that in street fighting, their machines became sitting ducks against nimble opponents. Things got especially bad when they ran into Allied air power, which owned the skies over France. Fighter bombers armed with rockets hunted any armored vehicle that showed itself on the roads during daylight. Tankers could only move at night, spending their days hiding under camouflage nets in groves and orchards. Any attempt to maneuver was spotted by aerial observers, and within minutes, bombs and rockets came raining down. Fighting in French towns turned into a nightmare for Panther crews. In a few cases, individual tanks pulled off impressive results, but those were the exceptions. More often, the vehicles fell into traps on narrow streets, getting hit by anti-tank weapons fired from upper floors and basements. Pulling a knocked-out machine out of an urban area was nearly impossible, and tanks were left behind for the enemy. The Allies carefully studied captured vehicles, noting both their strengths and obvious weaknesses. In late 1944, High Command launched the last major offensive on the Western Front. The Ardennes offensive was supposed to split the Allied forces and reverse the course of the war, with Panthers forming the armored spearhead of the Panzer divisions. On December 16th, troops attacked in dense fog that kept Allied aircraft grounded. The first days of the offensive went well. Armored columns pushed forward, overwhelming the disorganized defenders. But then the weather cleared, and Allied fighter bombers were back in the sky. The fuel crisis hit the tankers harder than enemy fire. The gas-guzzling Maybach engines burned through fuel at an incredible rate, and supply convoys couldn't keep up with the fast-moving columns. Dozens of Panthers sat abandoned along roadsides with dry fuel tanks, left behind by their crews. Allied soldiers found perfectly operational machines that had been ditched simply because there wasn't a drop of fuel left. The T-34's diesel engine burned nearly half as much fuel, a practical advantage that came from the Soviets choosing diesel for their own logistical reasons back in the late 1930s. On the Eastern Front, the Panthers faced a formidable new opponent. Soviet armored forces were now fielding heavy IS-2 tanks armed with 122mm guns. These guns could punch through the Panther's frontal armor from well over half a mile, drastically shrinking the range advantage that Panther crews had relied on. A well-positioned Panther could still be dangerous, but the margin for error had all but disappeared. The balance of power was shifting fast. The quality of armor on the latest production machines had dropped to critical levels. Shells hitting the glacis plate wouldn't punch clean through, but they caused catastrophic damage on the inside. The armor would crack, and spalling fragments would injure the crew and wreck the equipment. Steel mills cut off from supplies of alloying metals were producing steel that only looked like proper armor plate on the outside. Frontline reports started filling up with complaints that tanks were catching fire from hits that previously wouldn't have caused serious harm. The January offensive of 1945 shattered the defensive lines in Poland. Soviet forces punched through the front, bypassing strong points and pushing toward the German border. The Panthers found themselves playing firefighter, getting thrown in to plug gaps in a crumbling front. But there were too few machines and even fewer trained crews. The veterans who had fought at Kursk and Normandy were dead or captured. Their places were taken by yesterday's cadets with minimal time behind the controls. In the battles for Budapest and near Lake Balaton, the Panthers showed what they could still do in skilled hands. Tankers used the terrain, fought from ambush, and inflicted serious losses on the advancing forces. At the close ranges of urban combat, the advantage of that powerful gun still counted, and experienced crews were knocking out several enemy tanks a day. But every lost Panther was irreplaceable, while the Allies kept feeding fresh equipment into the fight. In the spring of 1945, the fighting moved onto German soil. Panthers fought in the streets of cities amid ruins and rubble. Crews put up desperate resistance, knowing there was nowhere left to fall back to. But the mechanical condition of the machines kept getting worse. Spare parts had stopped arriving altogether, and fuel was rationed drop by drop. Tankers drained gasoline from knocked-out machines, pulled wheels and track links, cannibalizing vehicles just to keep at least part of the unit running. The last Panthers met the end of the war in Berlin and Prague. Exhausted crews who had run out of ammo and fuel abandoned their machines and tried to push west to surrender to the Americans or the British. Allied soldiers captured abandoned vehicles by the dozens, often in perfect working order, but stuck with bone-dry fuel tanks. All told, over the course of production, over 6,000 Panthers were built, and the vast majority of them ended up the same way: burned out on the battlefield, abandoned without fuel, or smashed by aircraft on the march. The tank that was born out of the shock of encountering the T-34 never managed to overcome the fundamental trade-offs that plagued it from day one. A superb gun, well-designed frontal armor, and comfortable crew conditions couldn't make up for chronic unreliability, excessive complexity, and enormous production costs. Each Panther ate up so many resources and man-hours that several simpler but more dependable machines could have been built in its place. The story of the Panther is a textbook example of how technical brilliance in individual components can go hand in hand with overall failure when reliability, ease of repair, and real-world frontline practicality get left out of the equation.